All right, so we got ourselves a set of notes here to help you with Monday's assignment. Got some logarithms on there because a couple of you guys still haven't quite figured out logarithms. Nor have you kind of figured out basic algebra. Isolating is what we do. We always isolate. We do easy things first. 36 minus 12 is 24. Of course, that's some of the issues. Some of the issue is we have to go to a TI-84 and we have to type in 36 minus 12. And then we just write a new line. A lot of us don't like to write new lines. We divide out the 3 because that's the next easy thing to do. And the goal here was to isolate the base of e. 24 over 3, by the way, is 8. And then we get to do log is bay. Base, exponent, because it's high and small, argument. So we are going to have ourselves a log base e. Its argument is 8, and it's going to equal 2x minus 5. Log base e is also known as the natural log. So the natural log of 8. We're going to counteract subtraction with addition. That's nothing new, although some of you act like every day is a new day. And then we have the natural log of 8 plus 5 is equal to twice x. So we're just going to divide out that 2, right? Divide out that 2, and we are done. That's how hard that is. It's super duper easy. All right, solve 3 logs, base 6. Notice how I say it? 3 logs, base 6, argument 4x plus 5. Take away 4 is 8 by isolating. Isolating, that's all this stuff is. Like, I wish that would click. Isolating. So the easy thing to do is to add 12. The next easy thing to do is going to be to handle that 3 out front. The opposite of multiplication has always been addition. And that'll isolate the log. We'll have a singular log base 6. Her argument will be 4x plus 5, and it will equal 4. And now we're going to exponentiate. 6 to the 4th is 4x plus 5. And 6 to the 4th is going to be a big number. It's 216 times 216. I don't know it. I know what 6 cubed is, but 6 to the 4th, never memorized it. 1296. Why did I say 260? 36 times 36. 1296 equals 4x plus 5. All right, keep isolating. Remember, the whole goal was to get at x. Some of y'all haven't quite figured that out. I grade your test and you stop like you're done. But if it's solved for x, you get to x. So we subtract 5 and we get 1291. That would be 4x. Then we divide by 4 and we're done, because 4 is not going to enter that number because that's an odd number. Even numbers don't enter odd numbers. Solve by rewriting each side such that the bases are common. It's supposed to be an easy skill, but it turns out it's not. Some of it's because you guys just won't even bother to think. Like you're holding a TI-84 and you don't press powers of 2 to get a 32. 32 is 2 to the 5th. Always has been, always will be. So 2 to the 5th, we already had 4x minus 12 up high. 1/2, I know you don't believe me because you don't understand exponents, because you didn't want to memorize any of the stinking rules. If I raise it to the negative first power, I get a 2. So 2 to the negative first is equivalent to 1/2. And again, I know you don't believe me. You've been letting TI-84 tell you how to do math for your entire life, or some calculator, because you just don't want to figure it out. 0.5. And if you don't know 0.5 is 1/2, you're dum-dum. So anyways, I rewrote 1/2 as 2 to the negative first. The exponent is still 3x minus 4, but there's a negative 1 out front. We have a property that says if I have a base to the x and I have another base to the y, and the bases are identical, then x is y. So I'm going to distribute here. I'm going to have 20x minus 60, and I'm going to use this property. I'm going to set the exponential space equal to each other. And then I'm going to solve for x by putting x's on the left and numbers on the right. So that'll give me a 23x, because I swore I changed color. And that'll give me a 64. And I'm going to divide out my 23, because that's what I do. And I do not believe that will simplify. It shouldn't. 64/23. Easy peasy lemon squeezy. Slide 4, solve by condensing the logarithm and exponentiating, determine which solution is extraneous. So we're just going to use this small property. A log of a times b is broken apart as log a plus log b. And we're just going to read it from right to left. I condense addition through multiplication. So a singular log base 5 that contains the product of x and x plus 4 is still equal to 1. I notice when y'all were doing this on your own, a lot of you guys just forgot it was a logarithm. It just disappeared, but it's a logarithm. Before I do the next step, I feel like cleaning this up. This is x squared plus 4x. I have a base, I have an argument, and I have an exponent. I am going to exponentiate. See where it says exponentiating? 5 to the first is x squared plus 4x. Anytime I have what we call a quadratic, because that's what this is, some of y'all haven't figured that out yet. Your math vocab is just horrible. I set it equal to a 0. Or if there's no x's to say, I don't. But usually I set them equal to 0. This one will factor. It wasn't meant to be a killing problem, but it does factor. To create a negative 5, yes, we need a 1 and a 5. To be negative, one of them has to be negative, but we have to add the 4, and 5 minus 1 is 4. Still equal to 0. We're going to use that zero product property. That kicks in. X is a 1 or x is a negative 5. Now, which one is real? If you have a logarithm, argument a, the argument must be bigger than 0. If I plug that one in there, I have a log 5 of 1, and I have a log 5 of 5. And this is okay. It's 100% okay. In fact, look what it does. Because of our ability to merge, it creates a log base 5 of 1 times 5, which is log base 5 of 5, which is 1, which equals 1. So it works perfectly. It's the correct answer. Some of you guys will get that, some of you won't. Now, if I plug the negative 5 in there, I would have a log base 5 of negative 5 plus a log base 5 of negative 1, which does not work. Because I don't care what it is, if you take the log of a negative number, calculator not happy. Doesn't matter if it's a log, an ln, a log base frowny face, or one of Parker Scott's logarithms, still won't work. This one is real. And this one is extraneous. It has nothing to do with the sign on the x. It has to deal with what happens when you plug in. Recursive rule is given, write out the first 5 terms. So this guy is the previous term, okay? So we'll start off, it says plain and simple, if n is 1, then I'm negative 3. For a sub 2, the next term, it says look at the previous term. It is the previous term plus 7. Okay, so the previous term was negative 3. If I add 7, I'm sitting pretty at 4. A sub 3 is the previous term, which is 4. Add 7, which is 11. A sub 4 is the previous term, which is 11. Add 7, which is, that's 11, 18. And finally, a sub 5 is the previous term, which is 18. Add 7, 25. Easy peasy, lemon squeezy. But there'll be kids who don't, they'll be like, I don't understand Milbrath. I wouldn't tell somebody if I didn't understand how to do this. Like, I wouldn't, because they're going to judge you hard. All right? All right. So here what we have in words is we have 2 times the previous term. This is a geometric or exponential sequence. So the first term is a 4. The second term is twice the previous term. All you have to do is realize what a sub n minus 1 is short for, because nobody wants to write previous term over and over and over and over. So it's twice a 4, which is an 8. Ace of 3 is going to be twice the previous term, which was 8, and twice an 8 is 16. Ace of 4 is again twice the previous term, which was 16, which is 32. And lastly, the fifth term is twice the previous term. So twice the 32 is 64. Moving forward. Determine if the series shown is arithmetic or geometric, then find the sum using the appropriate formulas. Obviously, I can look at these things and tell you what they are. A lot of you should be able to as well. With that being said, the majority will not. So for the majority, to determine what a sequence is, find 3 terms. It's slow, but a lot of you guys just refuse to memorize anything that's ever told to you, because every day is a brand new day. I don't know how you exist having all the same experiences feel like they're brand new every single day of your life, but whatever. This thing starts at 2, by the way, because I know some of y'all have the memory span of Dory. She was that fishy, right? Yeah. Anyways, this is the sum of the 2nd through the 30th term. So let's see what kind of sequence this is, because that decides if we use the right formula or not. So f of 2 happens when you plug a 2 in. And if I plug a 2 in, I'm going to have 4 times 3, which is 12. I'm going to get a 10. F of 3 happens when I plug a 3 in. And you need 3 terms. You got to have 3 terms to establish a pattern. Truth is, you should probably do 4 or 5, but 3 is usually enough. So 3, not cubed, but squared, is 9. Aw. And 3 times 9 is 27. Take away 2, you get 25. Okay, so at this point in time, I'm doing one of 2 things. I'm either adding 15 or multiplying by 2.5. One of the 2. One of the 2 things is happening, okay? All right, let's see what happens if we find f of 4. That'd be 3 times a 4 squared. And then minus a 2. So 4 squared is 16. 3 times 16 is 48. 48 minus 2 is 46. So you can kind of tell here that the pattern broke. So this one is neither arithmetic or geometric. There's neither one of them. So you don't do anything, because I didn't teach you that formula. I used to back in 16, 17. They used to have to do this stuff, and they didn't like it. We used to take Riemann sums into some really deep territory. All right, what about this guy? Again, this guy is the sum of the 5th through 21st terms. And you're going to need the first one anyways. Like, you have to have the first term. It's called ace of 5. It's 3 times a 5 plus a 4, which is 19. So let's see, and to make sure what it is, let's see if it's geometric. The next term we plug in a 6. That's going to be 22. The next term we plug in a 7. That's 25. So you should be able to look at these and you should be able to decide that there's a common difference of 3. Now, I know, and I've said this with y'all before, but all, and I mean this, all arithmetic series or sequences look like y equals mx plus b. That's what they look like. Plain and simple. They look like it, or they can be manipulated to look like it. So I knew from the start that this was going to be a line. Now I am wanting to find the sum for arithmetic. The sum of n things is n over 2 times the first, which in this case is ace of 5, plus the last, which is ace of 21. N is going to be the big number minus the small number, add 1. So that should be 17. So I'm finding the sum of 17 things, and it's a 17 over 2. The fifth term was already found. It was 19. I am going to need to find the last term, a sub 21. That has to be done. 3 21s ought to be 63. If you add 4, you get 67. Let's see how much of this I can do by hand. So 19 and 67 is going to be 86. Half 86 is 43. So that's going to be 400 plus 280 plus 21. 701. Let's check me. I don't know that, and who knows? It's early in the morning. You can look at the clock at 6:34. I will say one thing, that these sequences, for some reason, I find them a little bit draining. I never quite figured out why. Some of them are hard. What we're doing in these little section of notes, it isn't too bad. But some of them require some brain power. Oh, I was wrong. There you go. See, mistakes happen. That's why I checked. Oh well, at least you see that everybody makes mistakes, right? Some teachers are afraid to make mistakes. Like, they have everything laid out. They literally will read their notes. When you go to college, those professors do not want to make mistakes in front of you. Like, they're afraid to make mistakes. I care less if I make a mistake. All right, now what is this guy? This one is actually going to be a geometric sequence. It doesn't look like it. Normally, geometric looks like 3 times, let me repeat that. I had a brain fart there. It looks like the first term times a ratio to the n minus 1. That's what we normally look like. I know this is 1, but we're going to have to figure it out. We're going to find the first term of our sequence by plugging in a 5, and it's going to be rather large. Oops. So 2 to the 5th is 32. If you multiply that by a 3, you get 96. All right, let's find another term. Plug in a 6. 3 times 2 to the 6th. 2 to the 6th is 64. That's what it is. And if you multiply that by a 3, you get 192. Now, I suspect that the next term is 192 times 2. That's what I suspect is going to happen. All right? Actually, I know that's what's going to happen. But let's see if I'm right. Because if I am right, then I just discovered that it's geometric. And I have the first term. So a sub 7 is 3 times 2 to the 7th. 2 to the 7th is 128. And 3 times 100 is 300. 3 times 20 is 60. So that must be 360. And then 3 times 8 is 24. So 384. And again, let's just check Milbrath. It's early in the morning. 3 times 2 to the 7th, 384. So I know some of y'all don't see numbers the way you're supposed to. 192 over 96 is 2. 384 over 192 is also 2. So what I have established here is I have a common ratio equal to 2. That means that this is geometric. That's what it means. Now, you are finding a Riemann sum. The sum of n terms is the first term, and this is geometric. This is geometric. Is the first term you care about, which in this case is a sub 5, times 1 minus the ratio to n over 1 minus r. N is always high minus low, add 1. Always is, always will be. So 21 minus 5 is 16. If you add 1, you get 17, right? 21 minus 5 is, 17. And this was also the ratio. There's some shortcuts when you actually memorize things and look how things lay out. So I'm going to find the sum of 17 things. It is the first thing, which is 96 times 1 minus that ratio. It is good practice to wrap that ratio in parentheses to the 17 over 1 minus 2. At least it is there, because that guy has an exponent. And this could be worked out by hand. There's really no point in doing it. So we got a 96 parentheses math num n over d 1 minus, and again, I'm going to wrap that thing in parentheses, and sometimes you have to, because like if it's negative, you better be wrapping it, or you have a 50-50 shot of getting it right or wrong. And that's sitting over 1 minus 2. Now, I guess just, for good teaching measure, I'll close the parentheses. Bam. Good old size number. 12,582,816. All right. 5 slides to go. Find the appropriate rule given the type and 2 terms. This one is arithmetic. So, if you don't know, and I want to point this out, remember these things look like mx plus b? Or we might have something like 6n plus 3. This is slope, and it's also your difference, right? Your difference is going to be the change in output over the change in input. That's the concept of slope. So my difference here says 76 minus 12. We work right to left, just like we did in 7th grade, over the input 19 minus 3. 76 take away 12, I feel like that's 64. And 19 minus 3 is 16. And I know that 64 over 16 is 4. So I have a common difference of 4. Now your task here is to write the explicit rule. All right. A sub n is the first term plus n minus 1 times d. If I didn't tell you that, some of you guys would probably do summation for some odd reason, because you're just weird. And I just need to figure out some stuff. But what I need for starters is the first term. And the thought process on this is I have the third term, it's 12. And I move right by adding 4, right? So if I wanted a sub 4, which I don't, it'd be 16. But I need to work backwards to the first term. So I'm going to be taking away 8, 4. First term is 4. So the nth term is 4 plus n minus 1 times the common difference, which also happened to be 4. And then I'm going to hit it with a distributive property. I'll have 4 plus 4n minus 4, and the 4's cancel, so I know that the nth term is just 4n. All right, moving on to 11. I'm trying to go somewhat quick and be somewhat thorough here. These are the rough ones. I know after all these years how kids feel about it. I'm sorry if you can't do it. I'm still expected to show you how to do it. You are told it is geometric, and the form for a geometric sequence is the first term times r raised to the n minus 1. So I'm going to talk about a sub 4. It is 6, and it must equal the first term times r raised to the 4 minus 1. So I know that 6 is equal to a sub 1 times r cubed. All right, I'm going to do the same thing for a sub 11. It is 768, and it must be the first term times r to the 11 minus 1, because I'm plugging into that formula there. That's all we do constantly, is find a formula and feed the formula and work our way out of the formula. That's it. So 768 must equal a sub 1 times r to the 10th. Now, the strategy on these is to always solve the smaller equation for a sub 1. So I said some words there. I said always solve the smaller EQ for a sub 1. It's just the easiest way to do it. So I divide both sides by r cubed, and that's what a sub 1 is. And then I use the substitution property. So 768 is 6 over r cubed times r to the 10th. And then we have the other issue, because some of us just haven't been trying for a long, long time, and we don't know what r to the 10th over r cubed is. It's r to the 7th, because 10 minus 3 is 7. You don't know simple things. And it's just maddening. Like, how do you not know that? But whatever. So 768 is 6r to the 7th. We divide both sides by a 6. You know, maybe we go push buttons, whatever. I don't know. I'm going to push buttons just to make sure I get it right. I feel like it's 128. That's what my gut's telling me. Actually, that's just what it is. It's 128. So 128 equals r to the 7th. You may or may not know what the 7th root of 128 is. I don't know, maybe you do. But you take the 1/7 root of both sides, because you're finding you take the 1/7 power, or 7th root of both sides, and then you'll have r. It better be 2, or I'm going to be highly surprised. If it's not 2, we've had a Mandela effect happen, because it's been 2 my whole life. So r is 2. Cool. Still not done. Take that 2, plug it in right there. So 6 equals ace of 1 times a 2 cubed. 2 cubed is 8. 6 equals ace of 1 times 8, which means that ace of 1 is going to end up being 3/4, because 6 over 8 is 3/4. So after all this fun work, I have figured out everything I need. I know that the first term is 3/4. I know that the ratio is 2. And that is how you write the nth term of a geometric sequence. Will I put one of these on your test, which you'll have Wednesday or Thursday? Of course I will. Do I expect most of you to miss it? Of course I do. Do I care? No. Do I want you to miss it? No. But you either figure it out or you don't, kids. It's really that simple. Figure it out or don't figure it out. All right, find the sum of the sequence. So your first task is, what is this thing? This thing is geometric. The ratio would be 5 over a -1, which is -5. And to double check it, it also has to equal -25 over 5, which is still -5. You are constantly multiplying by a -5. The other issue is, how many things are there? So you're going to need both formulas for geometric. You're going to need this guy, and you're also going to need this guy, because you are supposed to find the sum. Now, the good news is you already know the first term is, oh, this is geometric. That is the wrong formula. You need the correct formula. I had my mind on arithmetic, that the sum of n things is the first thing times 1 minus r to the n over 1 minus r. All right, so I have the first term. I know the ratio. I don't know how many things there are. So that's where this comes into play. This -9765, 625 must equal that formula right there. And I know the first term is -1. I know the ratio is -5. Notice the use of parentheses. And it's raised to the n minus 1. Logarithms are about to come into play. Okay, I have an exponential equation. So the very first thing I'm going to do is I'm going to divide out this negativity. Kind of interesting. And anyways, that'll give me the positive 9765625. And that'll free this guy up. I just don't like the way this one looks. I don't like it at all. I have to throw away the second negativity. This is kind of one of those cases in math where you just have to do something for it to work. It has to be thrown away. A lot of times it works out that you can divide it out, but it's not going to on this one. It just has to be thrown away. Because if I didn't, I would have a logarithm of a negative base, which you just cannot do. You can when you do it by hand. You cannot do it when you do it by technology. And that's the reason I just have to throw that negativity away. It's going to be okay. It'll all work out. We're going to have a singular log of base 5. Its argument is that gigantic number there, 9765625, and it equals n minus 1. So I go to my trusty TI-84, I do change of base. You guys are probably not hearing me say some important things there. Things can be done by hand, or they can be done with technology. Technology is the real issue here of having that negative base. Nothing wrong with having a negative base. And that's divided by the ln of 5. And I should get a nice little number here. I did, I got 10. So 10 equals n minus 1. So n is 11. So now I can actually turn around and find the sum of the sequence. The sum of 11 things is the first thing, which is negative 1, times 1 minus the ratio, which was negative 5, and it needs to be wrapped right here to the 11th power over 1 minus a negative 5. And then I can go to my trusty TI-84 and I can push the buttons and I'll get an answer. So negative 1, parentheses, math, num, n over d, 1 minus parentheses, negative 5. This is why it's important, because it's going to get raised to an odd. Well, actually an odd, it doesn't matter. It's when you get raised to an even that it matters. 1 minus a negative 5. There you go. That's the sum. 8,138,021. All right, we got 2 left. I know these are taking a while. It's just so much. Find the sum of this sequence. And that sequence should be arithmetic, because I know that a half plus a half is a 1. And 1 plus a half is 1.5, which is 3 halves. I know some of y'all still think decimals only, but I know it's arithmetic. And I know that I have a difference of a half. So the question is, how many terms are there? Whether you like it or not, you have to do it using this formula, that the nth term is the first term plus parentheses n minus 1 times d. Now, there's some shortcuts to this. I don't teach them because kids just don't ever memorize them, right? So stick to the formula. That's what they're for. I know that the last term I have is 52. It must be the first term of a half plus n minus 1 times the difference of a half. Now, when I look at this problem, I don't like the fact that there's halves. So I'm going to take a 2 and I'm going to distribute it to every, because before I change colors, every single individual piece. And there's 3 pieces of this function. That'll give me 104, it'll equal 1, and this will cancel n minus 1. Cool, the n's cancel. There are 104 items in this sequence. There is a shortcut to this. Maybe you'll figure it out here. I just don't want to teach it. But there's 104 items. And that's what I'm going with, okay? Anybody's noticed the shortcut? Maybe you have, maybe you haven't. So there's 104 items. So I'm going to find the sum of 104 things, and this is arithmetic. So I better make sure that I use the right formula. N over 2 times the first term plus the last term So the sum of 104 items is 104 over 2. The first term is a half. The last term is 52. And, you know, at this point in time, I'm going to do some of this. I know that's 52. That's 52.5. You just type it all in if you want. 2730. What if I told you there was an even bigger shortcut? Problem is I can't show it to you. All right, how many terms of the sequence negative 315 we need to get to the sum of 4,557? So I notice that I'm adding 4. So this is definitely arithmetic. At this point in time, you should have seen this demonstrated to you twice now, maybe 3 times, and you should have also practiced it 2 or 3 times by now. So you ought to be there unless you actually didn't pay any attention or didn't do any of the practice. So you shouldn't struggle too bad with this. There's my formula. The sum is 4,557. It must equal n over 2. N is the question. The first term is negative 3. And then I have the last term. And to use the last term, to find the last term, I actually cannot find its numerical value. But I can use this guy right here. And it's magic, but it makes it go from a 2-variable equation to a single variable equation. I know that the first term is negative 3. I have no idea what the last term is, but I know what the common difference is. It's 4. The good Lord has blessed me with a mastery of the distributive property. I combine like terms, and I get 4n minus 7. I can put a 4n minus 7 right there. All right, what else can I do? I can clean up the interior. I'll have 4n minus 10 because negative 3 minus 7 is negative 10. And I don't like the fact that it's got a fraction, so I'm just going to double both sides. It's an easy thing to do. 9,104. You guys see me like change the color, right? Equal to, 2's cancel, n times 4n minus 10. So 9,104 equals 4n squared minus 10n. This is something that you're expected to just see a quadratic and know what to do, kids. It's not supposed to be something that you ponder your existence on. But for some reason, y'all still like to struggle with these. There you go. There's your equation. I know that this thing probably does factor. You could make it smaller. I feel like everything's, now you could divide a 2 out, make it a little smaller. But I'm not going to attempt to factor that. I'm just not doing it. Let me shrink it up so I've got some room here. It's going to be the quadratic formula on these because the numbers are just gigantic. And as good as I am at factoring, I don't feel like wasting 4 or 5 minutes of your time doing it. So x equals negative b plus or minus square root b squared minus 4ac. All over 2a. All right, so you were trained. Do this first. Shouldn't deviate from your training. The reason you're trained that way is because a lot of times we have things where the standards want us to simplify the radical. We're trying to learn how to think with perfect things. So that's what's in the radical. Unless I messed up, it's going to have a square root. Uh-oh. That's no bueno. That is not good at all. That means that somewhere in this problem I have messed up. So I need to pause this real quick and figure out this problem. So, little mistake. Won't take long to fix. That's a 14. There we go. Take the square root of that guy, and this will work now. I hope. Good, 382. 10 plus or minus 382 all over an 8. So if I do the 10 plus, I would have 392 over 8. If I do the 10 minus, I'd have negative 372 over 8. Well, you can actually have negative terms, but it wouldn't be a positive sum. 49. If I do the negative one, I got a decimal, so that doesn't make any sense in that aspect. So 49. I know that was a little long. There's a lot there. So have fun with that, kids.